Assalamu alaikum warahmatullahi wabarakatuh. I am recording this video to help you to make the simulation for pre-lab of experiment 6. As shown, this is RLC circuit, which has inductor, capacitor, and a resistor. Also, it is part of AC analysis. So we are going to use multisim as a simulation tool to make this circuit and get some related value regarding time shift and phase shift. So let's get started. We have here voltage source, resistor, capacitor, and inductor. So we are going to insert these elements into multisim. So first I'm going to look for AC source. So we have here three sources. For AC, for example, I could use AC voltage if I'm going to put voltage peak, and AC power if I have the voltage as RMS. So these are the difference between the things. Of course, I could convert between VRMS to V peak, but if it is given on the example to put V peak, so no need to convert, just choose the suitable component. So here we have VRMS 2.8 to 8, or we could simply use for voltage peak or 8 voltage peak. So you could either choose one of them. So I would like to use this and make it 8 volt. Also, what about hertz? This 15 kilohertz. After that, I'm going to look for the other components, inductor, and make sure to search at all groups. I'm going to use inductor rated. Capacitor. Also, I'm going to use capacitor rated. For RC circuit, we used the polarized one, but here we are going to use the non-polarized capacitor, and I'm going to get a resistor. Get the ground. So now let's configure the value for each component. We have here 1 kilo ohm resistor. After that we have 10 millihenry. And for the capacitor we have 0.022 microfarad. And here notice that in the comments put 4 ohms resistor after the inductor in series. To put it 4 ohm. Connect the circuit. Connect the ground. And get the Tetronics oscilloscope that we managed to use it on our lab. Connect the ground to the ground. And here for channel 1 I am going to measure the input voltage or the input signal, and for channel 2 I am going to put it across the capacitor. So I am going to start simulation and open the Tetronics oscilloscope and power on. make channel 2 on also, single sequence. After that I'm going to enlarge second pair division, enlarge more. Yellow signal is for the input source, signal of the input, and the blue one for the output, which is across the capacitor between node number 4 and 0 and the ground. And right now I am going to get measure button. For channel 1 I am going to measure V peak to peak. Sorry guys, this should be 4. I'm going to stop simulation. I noticed a problem here that I used for the value of V peak, use 4 as peak, but from peak to peak it is 8, so put it 4. After then run again, and also I am going to get the second source for channel 2, measure V peak to peak, it is 4. So now I have the input voltage is 8 and the output is 4. So here for the first question it is asking about V source. So the theoretical V peak is 4, so in simulation it is 7.98 peak to peak, so divide by 2 and put the number here. After that I am going to make an example on VC, and I will leave the rest for you to make. So now I am asking about V peak for the capacitor. So here it is 4.02, and notice that it is peak to peak, so you need to divide by 2, so it will be around 2, so put here 2. Right now I am going to measure something called time shift. For example, if I have 2 signals, there might be shift between the signals. One is leading the other and the other is lagging. One signal shows first and the other one is coming late. For example, here this signal was, for example, 0 at this point, but the second signal. Right now I'm going to put the 2 signals on top of each others. Note that channel 1, the scale for each box is 5 volt, scale of y-axis for each box for yellow one is 5 volt, while each box for the blue one is 2 volt, and here each box for x-axis is worth 20 microsecond as period for both signals, or all signals that you have connected. Right now I am going to use cursor. If you activate it, type choose instead of voltage will give you cursor, which is for y-axis, but we need for time, so it will give us cursor like this. So I am going to manipulate it and get another cursor and put it on the second peak. One for first cursor for first peak and second cursor for second peak, and we are interested on getting the delta between them. So delta here is 24.4 microsecond. You have to enlarge, proper enlarge second pair division and manipulate it for the peak, exact peak, in order to get accurate result. So here is the delta 21.2 microsecond. To determine the sign, for example, here we have the output signal and we have here the input signal. If the output signal right to the input signal, put negative. If it is left, put positive. Okay, and we are interested on calculating the distance between, for example, two peaks maximum or two peaks minimum, or between when the signal reaches 0 and the other 0. So it is important to get focus and use similar things. If you have here put the first cursor on the maximum, so put the another cursor on the next or the nearest peak for the second signal, which is the output. So right now I am going to put delta here is 21.1 microsecond on time shift in microsecond. Write this number here, and of course it is negative because the output signal is right to the input signal. After that, you have to calculate phase shift in degrees. How to calculate phase shift? There is a formula. You are going to multiply the time shift that we got right now by the frequency, which is 15 kilohertz, and then multiplied by 360 degrees. This will give you the phase shift. Make this for theoretical value and make it for the simulation value, and put here the phase shift in degrees. So now we are done with the first row and the fourth row, and what I need from you is to continue as we have discussed for second, third, and fifth row. How to make this? The only thing that is going to be different is to replace capacitor by an inductor once and by a resistor once. So for example, I'm going to copy this So now I have changed the order. I have replaced the resistor by a capacitor, changed the order here, and right now my load is the voltage across the resistor. And I'm going to make the same for the second Tetronics oscilloscope. Measure the V peak for the load, and also get the time shift, and from the time shift convert it to phase shift. And you are going to put the values that you get on VR, okay? While VL, you are going to make same. You are going to replace the inductor by the resistor. Make the resistor at the end, which is nearest to the ground. It has common ground, and from here you are going to measure the V peak across the inductor and also the time shift. For the last line, to calculate I source, so from Ohm's law, it will be voltage over the resistor. You are going to divide VR simulation over 1 kilo ohm. It will give you I peak source. And for time shift, it will be same exactly as the time shift for VR, and same phase shift. At the end, do not forget to include screenshots. For example, for the first row, put one screenshot. Second row, put another screenshot. How to calculate the peak value and the time shift, and so on for all the rows of the table. For more information, you could refer to the lab manual. You will find detailed steps, and this video I think will be fine if you go on the same procedures. You are fine to get correct values. Thank you and see you next time inshallah.